We're going to try and make this as easy as possible for you. We're going to be spending the next few days on graphing trig functions. Tend to be a little more challenging for students as we go through things. And just remember they all relate back to our unit circle, okay? So with our sine and cosine graphs, as you can see, you guys, we're going to be graphing waves, all right? These are all each called sine waves. The height of each wave is called the amplitude, okay? And then again, just like we said in the last lesson, the horizontal distance it takes to complete one cycle is called the period. Those are the two probably easiest things to find and determine from the graph. Keep in mind, most of what we do, you guys, is going to be in terms of radians, okay? So I know it says 360 degrees to complete one cycle. We're most likely going to be sticking to that radian measure as we move on through things. As you continue on to pre-calc and calc, radians are going to be more important than degrees, okay? So basically those are the two things we need to find, and then we'll actually go into constructing the graph. The one thing I do want to mention before we move on, there is a formula to figure out your period, and it's always going to be 2 pi over b. Always, 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 okay? And that's when you have your equation in this form. So we have a sine bx or a cosine bx, all right? And for the first day, we're not going to be shifting our graphs up and down, left and right. They're always going to be kind of centered around the origin, and we'll note two differences between sine and cosine, okay? But we're going to walk you through a way to relate it back to the unit circle and hopefully help you graph these. So first things first, we're looking at the sine wave. We want to figure out the amplitude and period of this graph. Probably the two easiest things to figure out. Again, the amplitude is going to be the height, and that's always related to your A value, okay? Please, please, please make sure that when you report the amplitude, it is always a positive number, okay? Your amplitude is never negative. It is always going to be a positive number. So if you want a general formula to write down, your amplitude is always going to be, on today's lesson, the absolute value of A, okay? Then we want to figure out the period of this graph. Well, just like I said before, our period's always 2 pi over b, which in this case is pi. Pi's cancel, so my period is also 2. At this point, I really like to go to my graph, okay? So I know the period is 2. So I know that whatever the cycle is going to be, it's going to start with sine at 0, and then I'm going to finish at 2. And then I just need to figure out the wave in between. Keep in mind, sine, in the meantime, always starts in the middle of the curve, as you can see up here. Cosine always starts at a peak. And that's kind of the difference between the two, for today at least. All right? So the question is, how do I figure out all those other key points on my graph? Well, easiest thing to do is cut your period in half. Half of 2 is 1. Half of 1 is a half. And then what's halfway between 1 and 2? 3 halves. Then we can go into constructing this graph, all right? And just so you guys know, it's really related back to our unit circle. So when I start with 0 here, what I'm going to do is I'm plugging in 0 for my angle. What is 0 times pi? Well, that's 0. So essentially, I have negative 2 sine of 0. So if I think about my unit circle, what's the y value at 0? Well, 0. 0 times negative 2 is 0. So I'm picking the value off the unit circle. When I plug in a 1/2 for my angle, again, theta is your variable. 1/2 times pi is pi halves. So I'm just going to write over the 0. We have pi halves. Well, if I look at my unit circle, pi halves is actually up here. What's my sine value at pi halves? 1. 1 times negative 2 is negative 2. All right. Then we can do the same thing again. All right, so we'll start our equation over. This time I'm going to plug in a 1. So negative 2 times sine of 1 times pi, which is just pi. The sine of pi, if we go to our unit circle at pi radians, the sine value is 0. 0 times negative 2 is 0. Again, continue on. All we're doing is plugging in our x values we have in black for our table, or for our function. So now I plug in 3 halves, so I have negative 2 times the sine of 3 pi halves. If I look at my unit circle, I've rotated down to 3 pi halves. The y value at 3 pi halves is negative 1. Negative 1 times negative 2 is positive 2. And then, of course, we finish our pattern back at 0. So that is your sine wave. We can do the exact same thing with cosine. There's just one little catch in terms of its difference. So, looking here, our first step is always figuring out the amplitude, which in this case is 4. So my graph is going to go up to 4 and down to negative 4. The second thing you want to determine is your period. Our period's always 2 pi over b. B in this case is 3. So I know my period is 2 pi thirds. So I can write that on my graph because I know I'm going to start at 0. And I'm going to go out to 2 pi thirds and complete one cycle. At this stage, you want to figure out those key points. And those key points on your graph are always going to be halfway, which in this case is 1 pi third. Half of 1/3 is a sixth. And then if we have 1/6, 2/6 is a third. The next increment is going to be 3/6, which is pi halves. So we have all of our key points graphed out here. Now we just want to figure out our function. So I start at 0, and I plug in 0 to my equation. So now I have 4 times the cosine of 3 times 0 is just 0. So I'm thinking about my unit circle. If I go to 0 radians on my graph, the cosine at 0 is 1. 1 times 4, my y value is 4. Continuing on, we go to our next point, which is pi 6. So we have 4 times the cosine of 3 times pi 6. 3 pi 6 is pi halves. So I'm up here. What's my cosine value there? Well, my cosine value there is 0. So this whole thing goes away. 0 times 4 is 0. At this point, some of you may be picking up on the pattern, which is awesome. And you could probably just fill in your points from here. Since we know our graph is going to oscillate between 4 and negative 4, and our graph is trending downward, I can see that at pi thirds, I am likely going to be at negative 4. Pi halves, I'm going to be back at 0. And then I always end and finish at the same spot I started. And then we just connect our wave. Make sure to not draw your points above the amplitude because our graph is going to hit that point and come back down. All right? But that is what your sine and cosine graphs look like. Again, amplitude and period is going to be your first step. Then I would set up your graph according to your period, breaking it up into a half, and then a quarter and 3/4. And then you want to plug those values you found for x into your equation, referring to the unit circle to figure out your y coordinate at each of those points. Continuing on, you may have some word problems today to look at. Very similar to before, if our frequency, sound has a frequency below the human range, is known as infrared sound. Elephants can hear sounds or hear in the infrared range with frequencies as low as 5 hertz or 5 cycles per second. So the first part is find the period of this function. Well, remember, our period is how long it takes one cycle to complete. So if I have 5 cycles per second, I know the period is going to be 1/5 of a second, because every 5 cycles is going to be a second. So if we want to graph this, we want to come up with our equation. It says write the sine function. Again, today our sine function is always going to be in the standard form a sine bx. Well, it says let our amplitude be 1. So my a value is going to be 1. And then the question is, what is b? Well, I know that, remember, my period is always 2 pi over b. So if I were to cross multiply here, b times 1 is b, 5 times 2 pi is 10 pi. I know that my b value in my equation has to be 10 pi x. And then that's the equation I'm graphing. All right. Then from here, just like we did before, when we're graphing, we want to run through those things. So our amplitude, as we said, is 1. Our period is 1/5. So that's where I go to on my graph. I start at 0, I go out to 1/5. And then you want to take half of your period, which is 1/10. Half of a tenth is 1/20, which means 3/4 of the way is going to be 3/20. And then from there, all we need to do is plug things in. So if I plug in a 0, 10 pi times 0 is 0. The sine at 0 is 0. 0 times 1 is 0. If I plug in a 1 over 20 for x, 1 over 20 times 10 pi is going to be pi halves. The sine, or our y value at pi halves, is 1. 1 times 1 is 1. And then, again, if you know the pattern, we're going to continue on that same idea, and we can finish off our graph. Okay? Super important as you guys are going through this, you're able to determine the x values, because that's going to be where you pick those values to plug into your equation to figure out the y coordinate at those given points. If you set your x-axis up like we have been, where you go out to the period, take a half and a half, and then 3/4 of the way, you're always going to hit those peaks today. When we have shifts, things are going to change, but we're not there. All right, so that's another example with sine and cosine. The last example we want to take a peek at is tangent. Tangent graphs, you guys, look a little different, as you can see from the picture. There is no amplitude because they go up and down forever. And then keep in mind our period is always based on 180 degrees instead of 360. So in terms of radians, our period is going to be based on pi radians instead of 2 pi. So when we are calculating our period with tangent graphs, it's important to remember it's not 2 pi over b like sine and cosine, it's just pi over b. So in this case, again, remember there is no amplitude to our graph. Sometimes we'll call it our halfway points, if you want to think of it that way, or the height of the halfway points is going to be 3. It is not an amplitude. And then the next thing you want to find, just like before, is our period. And our period in this case is going to be pi over b. Okay. Tangent graphs are going to be a little different. With tangent graphs, you don't want to go out to pi halves. All right. What you actually want to do is you need to figure out where the asymptotes are going to occur on your graph. All right. And how you figure that out today is you take your period and you multiply it by a half, which is going to be plus or minus pi over 4. And that is going to be where your asymptotes are on your graph. Pi fourths and negative pi fourths. All right. At this point with tangent graphs, we don't need 5 values to graph. We actually only need 3 values. Okay. So the question is, what 3 values am I going to use? Well, if you notice, right in the middle of my graph is 0. So that makes the most sense to plug in. But then you want to figure out what's halfway between the center of your tangent graph and the asymptotes. Well, half of a fourth is an eighth. Half and negative pi fourths is going to be negative pi eighths. And watch how convenient this is if we set up our graph this way. When I plug in 0 to my equation, 2 times 0 is 0. So I have 3 times the tangent of, not theta, 0. If I'm thinking about my unit circle, my tangent value there at 0 radians is 0. 3 times 0 is 0. And again, if you are using the formula sheet, our tangent values are actually on that formula sheet, so there isn't too much to think about. Now if I go over to pi eighths, if I plug in pi eighths times 2, pi eighths times 2 is 2 pi eighths, or pi fourths. So if I were to rotate up to pi fourths, you'll see your tangent value there is 1. 1 times 3 is 3. So at pi eighths, I'm up at 3. If I plug in negative pi eighths, I'm going to have negative 2 pi eighths, or negative pi fourths. My tangent value is negative 1. Negative 1 times 3 is negative 3. And then from there, we just connect our points. So again, tangent graphs are a little more confusing, but it's super important to, as you go through these, the very first step is figure out what the height of these halfway points is going to be, and that's directly related to your a value. Your next step with tangent graphs is figuring out your period, which is pi over b. Okay. Then you want to take your period, multiply it by a half to get the location of your asymptotes. Once you have the location of your asymptotes, you want to figure out how far the center of your graph is from those asymptotes. On today's graphs, the center should always be 0. So it should be an easy figure out for those values, or those halfway points in your table. Once you have your halfway points in 0, then all you have to do is plug those in for theta in your equation, use the unit circle to come up with your y values, plot them, and connect your dots. That's the lesson for today. Graphing sine, cosine, tangent. Again, there's no shifts. If you have any questions, feel free to utilize the discussion boards or join me for those live sessions. You also can shoot me emails or messages, but typically those are a little bit more challenging to kind of type through an answer versus actually talking to you or posting a video on the discussion board. Good luck today, and keep up the good work.